And then the rest of this chapter is all polynomials. 4.3, basics. 4.4, add, subtract. 4.5 and 4.6, we watched videos on them. For today's class, multiplication of polynomials. Was that pretty straightforward? Yeah? Yeah, no?
Mm-hmm.
Videos. Could you learn from those videos? Yes or no?
Yes.
Okay? Monomial times a monomial. It's all built on that, right? Numbers go with numbers. X's go with X's. Y's go with Y's. All that kind of stuff. Today, look at 4.7 is a review of these three. And 4.8 is just division. Like I said, we could teach those two things in about 10 minutes. Please look up here. You're going to make your first box. And this is my suggestion. You can make a visual chart any way you want, but you got to make it. It's got to be thorough. It's got to cover everything that we go over. I would make a big box for your laws of exponents. Have the 5 laws. We did like the hypothetical. We had an example. We had something we called the Mythbuster. Okay? And I would have quiz examples in here somewhere, like what we have right there. We've taken 2 quizzes now about the laws of exponents. We did one on Wednesday, 7 problems. We did one today, 8 problems, plus these 2 for scientific notation. These problems are just like the ones on the test. I mean, this is going to prep you for it. So, and same with the other quiz. So all those problems, great things to put in your visual chart. Then I would make 3 little boxes. Notice these aren't going to be in any order. One says, what's this? This is 4.1/4.2. We also, in 4.2, learned about scientific notation. I would definitely have these 2 examples from the quiz in here, and I'd have the explanation of how to put things into scientific notation. All the notes that we gave on that was in the video. And then I would jump into 4.4. Skip 4.3 for now. Addition, subtraction. That was distribute, parentheses, and combine like terms. We talked about this in class last Wednesday. Give you an example on that. I'd have some kind of example or 2 in there. And then 4.5 and 4.6, we're going to hold off on that. This is actually going to be section 4.8, division. You're going to see today we're going to have a big example to put in there and a very small amount of notes. So these 3 are very small boxes. I would have 4.3 right here. This is the basics of polynomials, and we had A through I that we went through, and I would have all that in there. And then 4.5 and 4.6, this should be your multiplication of polys notes that you extract from those videos, where we did have mono times mono, mono times any poly, bi times bi, and any poly, any poly. And you know, one of the things that we really highlighted here, I'm just going to throw this up here, is this concept of x plus 3 quantity squared. Okay? If you didn't watch the videos, shame on you. You know? You didn't have to go to class, so you didn't have to hoof it here. You saved all the time you had to walk here and walk away from here. We condensed the video into, what, 46 minutes? Yeah, I was going to say 45 minutes, so you got another 15 minutes shaved off. I mean, you shaved off at least a half hour of your day, and so you gotta watch, you should watch those videos. Well, here's the thing about x plus 3 squared that we taught very poignantly. Most people would think that this is going to be x squared plus 9. We said, don't smoke that dope. It's not true. And the reason is that we think that is because the power rule in the laws of exponents, this 5th rule, the power rule, says everything in the parentheses receives the power. But only when what? Only when what? What's inside the parentheses is a monomial. That's right. But this is a binomial, so we can't take the shortcut. We have to literally say, all right, this is x plus 3 times x plus 3. Well, when you multiply that out, you get x squared plus 6x plus 9 when you multiply it all out, okay? And so that principle is going to be tested more than once on this test. And so I would have that somewhere in this section of notes here. So when we meet on Wednesday and review for the test, we're not going to talk about the overall, chapter again. We're not going to talk about visual charts. That's your review for a visual chart and what all is in this chapter, okay? So now we return to this. What's going on here? So the chapter 4 exam. Numbers 1 through 8 are laws of exponent problems. And those are those 8 problems over there. And again, they're not identical, but really similar. Okay, you're going to be tested on all these concepts. And then numbers 9 and 10 are going to be scientific notation problems, and that's what these two are like. Okay, so let's go ahead and quickly do this. This is the product rule. Number one mistake. Number one error here. Students say, oh, 5 times 5 is 25. 25 to the 5th. That's the answer. Well, listen. Okay, have I ever made that mistake? Me? Yes. Okay, do I anymore? No, because I'm older. Okay, you're getting older. You know, you've gone through math. You know, let's put it this way. You are math adults. Okay, algebra adults. Okay, you've gone through algebra infancy. Then you went through algebra puberty. Okay, maybe a month ago. You are now in algebra adultery. No, adult. No, not adultery. That would be a sin. How about algebra adulting or something?
Yeah.
They don't have a good word for that.
Be a t-shirt.
What's that?
Be a t-shirt.
Yeah. All right, so check it out. That's not a 5. Okay, Kyle? You can do this, man. Stay awake, Kyle. That's not a 5. Well, no, that's a 5. 5 to the negative third is not 5, fetchers. It's 1 over 125. If you simplify it. That ain't 5. It's 125th. And that's not a 5. 5 to the 8th? I don't even know what the fetch that is. You know, it's a huge number. Okay? So you can't multiply those two 5s and call it 25. But what you can do is recognize they have the same base. That's right. They got the same base. And so that's 5 to the negative 3 plus 8. And since they have the same base, they're being multiplied, we can add their exponents, which just makes 5 to the 5th, and you are done. And we don't multiply that out. Why? Because it's too big to multiply out in our head. So we don't do it. This one right here, this is the negative exponent rule. Okay? So this is 1 over 6 to the second, and that one we are going to multiply out in our heads, because 6 times 6 is? Because we can do it in our heads, and so that's 1/36. People say, why didn't we multiply that one out? Because I didn't have to use a calculator. Why did I do that one? Because I can do it in my head. That's why. And that's how that's going to work. People say, well, not everybody can do the same amount of stuff in their head. I agree. But there are some kind of standard things that we know, right, in our times tables that we're willing to function with. You know, that is not something we know. This one right here, again, this is the product rule. Can I show you guys something interesting? This is x to the 5 plus negative 1, which equals x to the 4th. Do you all agree?
Yes.
Yeah? Say, woo, you got that right.
Woo.
Good. That's awesome.
Yeah.
But, can you do it a different way?
Yes.
Yeah, you can take x to the 5th over x to the 1st. You can bring that negative exponent down to its bottom. Then you can apply the quotient rule, say that's x to the 5 minus 1, that equals x to the 4th. I don't like that way. You know, I don't necessarily dislike it. I mean, it's accurate. You get there, but it just takes more work, more steps, right? And I like the path of least resistance because I'm a human, right? So I like just using the product rule. So I'm not going to cross that out because it's wrong. I'm going to cross it out because that's not what we're focusing on. But I'm just saying, if you apply the laws of exponents, you'll get the right answer eventually. Just keep applying them, right? This one right here, what's the answer to this? Everybody.
1.
It's 1. Yeah, that's it. And you know, this is the 0 rule, but in some instances, it's also the power rule. Because everything in the parentheses receives the power. I have 2 to the 0, x to the 0, which is 1 times 1, which equals 1. Okay? This one. This is the quotient rule. Quotient rule says same base being divided, I can subtract these. I get p to the 5 minus negative 8, which makes p to the 5 plus 8, which makes p to the what? P to the 13. Say woo if you got it right.
Woo.
Woo, woo, woo. Okay? This is the quotient and the negative exponent rule here. We're going to have x to the negative 3 minus 8, which makes x to the negative 11, which makes?
1 over P.
1 over x to the
11.
positive 11, right? Because we don't want to have negative exponents unless we're in scientific notation. That's the only time we can accept that, right? Power rule. Everything in the parentheses receives the power. Both of these are power rules. Okay? Look up here. This is going to be negative 2 to the 3rd, a to the 4 times 3. Therefore, we're going to have negative 8, a to the 12th. Okay? Why negative 8? Because we can take negative 2 times negative 2 times negative 2 and do that without a calculator and get negative 8. Cool?
Cool.
Okay. All right. Next thing. Everything in the parentheses receives the power. Tell me the answer to this one. You guys tell me. X to the
10.
10th over
Y
Y to the 25th,
Z to the 20th.
Z to the 20th. That's the answer. Done. Everything in the parentheses receives the fifth power through multiplication. Who got it right? Say woo.
Woo.
Woo-ho. Scientific notation. Okay, so you have 8 problems on the test from the laws of exponents. If you can do these, that's a third of the test, right? 25 problems. 8 times 3 is 24. A third of the test is the laws of exponents. You can do this, right? You can kick butt on this. Okay, so we're not going to review the laws of exponents any further beyond today. Okay? Scientific notation, by definition, is there's only one digit to the left of the decimal, but that digit can't be what?
0.
Can't be 0. Very good. Decimal, where is it right now? It's the end. Yeah, it's here. So we're going to move it. 1, 2, 3, 4, 5, 6,
7.
7. So we get 7.025 times what?
10 to the 7.
10 to the 7th, because you moved 7 places. It's a positive 7 because you moved the decimal left, or if you have this memorized, your original number was greater than 1. Okay? Cool? Say woo if you got that right. Sorta? Woo sorta?
I didn't put the 5 at the end.
Okay. Okay, you gotta have that. Can't get rid of it. Alright, so very interesting here. Same kind of a concept is multiplication of polynomials in the sense that numbers go with numbers. Base 10, goes with base 10. So watch this. We're going to go and drop that times down to the bottom. So we're just going to saw that right in half. We're going to focus on these two things. They're being divided. So go ahead and get your calculator out and do 2.35 divided by 8.2. 2.35 divided by 8.2. What do you get?
0.286.
0.2865?
Yep.
Okay, and we'll do this, we'll say times. Okay, 10, now let's think about this. Base 10 10 to the 5th over 10 to the negative 6 is 10 to the 5th minus negative 6. Agreed?
Yes.
Which is 10 to the 5 plus 6, which is 10 to the
11.
11th. Are we done?
No.
Why not? Gotta move the decimal point one place because we only want one digit to the left of the decimal, but that digit can't be,
0.
and right now it is
0.
So we gotta fetch and move it. So we're gonna scoot this over one place, and we're gonna call that 2.865. Don't even worry about this right now. Look up here. Don't worry about this. Just take this right here, times 10 to the negative 1. If we convert just that number there, it's this. 2.865 times 10 to the negative 1. Why? Because we moved to the right, and our original number was less than 1. Which is already times 10 to the 11th. Now, these have the same base, so I can say 2.865 times 10 to the negative 1 plus 11 makes 10 to the 10. Say, well, if you got that right. It's impressive. Okay? All right, so you have now covered 10 of the problems on the test. Okay? You cool? You covered about 40% of the test. And that's all we're going to do for review of the test today. Okay? We're going to teach you the new concepts for the rest of class. You guys good?
I want to
New concepts meaning like
4.7 and 4.8.
I thought we were talking about 5.1.
Chapter 5, man. We got to finish chapter 4 first.
Oh, okay.
We got 4.7 and 4.8 left to do. Okay. I want you guys to open up your textbooks today. I'm going to leave that problem from the homework up here for a bit. We'll see where we go with that. Okay.
Your collar's not straight
My what?
line. Your collar's not straight line like that.
Really?
Yeah.
I don't really care, but thanks, buddy. Kind of what adds with that. Join me in section 4.7. Okay, you guys good? All right, Alex. Better pause this for a minute, because I'm going to get crazy. Just joking. That's on all my other recordings. That joke's as old as this class, man. Gotta make fun of somebody's grandma doing a bong hit on that.
Did you say 367 or 377?
367. Okay. Since not all of you have a textbook with you, okay? Would you read that out loud for us right there? What does that say? Title.
operations with polynomials and several variables?
Okay, you sound like you are teaching a relief side
Sorry, do
lesson.
you want me to be a little more
Power
excited?
voice.
Okay,
Go for it.
okay. Operations with polynomials and several variables.
Would you like me to translate what that means? Yes or no?
Yes.
Okay, it means more of the same crap you've been doing with more variables in them. Does that sound good? Okay, more of the same crap you've been doing, but it's got more variables in them. Let's go back to Claire's grandma's page. Okay, page 371. All right. So let's first talk about part A in section 4.7. Remember, 4.7 is a review of 4.3, 4.4, 4.5, and 4.6, but it has more variables. All right? So I want to remind you, in section 4.3, we learned about the basics of polys. And in part A of 4.3, we learned a concept called evaluate polys. And the exact example used was x squared minus 5x plus 6, and we told you to evaluate it when x equaled -2. I got a question for all of you. How many variables are in that polynomial? How many variables are in that polynomial? Just one. There's 3 terms, but there's only one variable, the variable x. Yes, x is being squared here, but that doesn't make it a different variable. Now, what I want you to do, okay, somebody read problem number 3 to me. Number 3. Let's do number 3. Okay?
X squared minus 3y squared plus 2xy.
Okay, how many variables are in this polynomial?
2.
And notice in the beginning, the directions, it says to evaluate the polynomials when x equals what?
3.
3. Y equals what?
-2.
Okay, we don't care what z equals because there's no z in this one. Some of the other problems there'll be a z. This confuses students sometimes. They're like, oh, where's the z? So it doesn't. Look at some of the other problems. There's a z. If there's not a z, you're good. You know what I mean? Okay, don't hyperventilate about it. Okay? So we know how to evaluate. It's simply substitute. Where there's an x, we put in a 3. So we end up with 3 squared minus 3 times -2 squared, right? Plus 2 times 3 times -2. Agreed?
Yes.
Agreed.
Okay, so this becomes an order of operations problem. Do the exponents first. What's 3 squared? Everybody help me. 9 minus 3. -2 squared is what?
4.
4. Very good. Plus 2 times 3 times -2. So now we're going to multiply. 9 minus what?
12.
12. Plus 2 times 3 is?
6.
And 6 times -2 is? -12. So I have 9 minus 12 is -3. And -3 plus -12 is -15. Hard or easy?
Easy.
Yeah, you know how to do this. More of the same crap that you've been doing, but it has more variables, okay? You're not going to learn anything new in section 4.7. You're just going to be doing the same concepts, but with polynomials that have more variables in them. So if you're doing the same thing, but it has more variables in it, what are you going to need to do? What are you going to need to do?
Be more organized.
I love that.
Thank you.
Be more organized. You really do. Because you can totally botch things up if you're not being really thorough, really organized. Okay? Let's look at this crazy bong hit problem. Okay? Lung capacity. Okay? So is grandma really, is she really bonging?
No,
No.
it's not a bomb.
She's taking a breathalyzer test. No, she's not. She's actually measuring her lung capacity.
She's measuring like how much like when she exhales, the one of the little like cylinder things go up kind of thing.
Yeah, very good. And so look at this, guys. Problem number 9 says, find the lung capacity of a 20-year-old woman, obviously that's not a 20-year-old woman, who is 165 centimeters tall. Okay? Well, how do we do that? We go up and there's an equation, a polynomial equation. And it says C. C stands for capacity. What capacity? Lung capacity equals 0.041 h. What does h stand for? Height in centimeters. Did they give us height in centimeters?
Yes.
So what are we going to plug in for height for this problem number 9? 165. And then minus 0.01, what is that, 8?
8.
A stands for
Age.
in
20 years.
years. And so we're going to plug in what for this problem?
20.
20 minus 2.69. Can we do this?
Yes.
Just to be thorough problem, folks. This is easy stuff. We cool?
Yes.
Cool.
Okay, and remember, in section 4.3, I told you you had stuff that looked like word problems, but they really weren't word problems. They were just substitution problems. They're doing the same thing. Flip the page. Okay? Part B. All right? Nikita. Mr. Solovyov.
Yep.
You're the man. Dude, look, you got more testosterone in your vocal cords than I do in my whole body. Say hello.
Hello.
See what I'm talking about, man? I love it. Okay, would you read problem number 20 to me? Problem number 20.
6 minus xy plus 8x squared, y squared minus y in 5th power.
Beautiful. Okay, everybody. They're asking us in this problem, this is part B. This is number 20. You put it in your homework, you'll get extra credit for it. They're asking us to identify the coefficient of each term, the degree of each term, and the degree of the polynomial. So help me out here. I don't want 2 people answering these questions. I want all of you participating. What is the coefficient of the first term? 6. Everyone, what's the next one?
-1.
Next one.
8.
Next one.
1.
Negative 1. Okay? What's the degree of the first term?
1.
We
0.
talked about this.
0.
It's not 1.
0.
It's 0. Remember, okay, please listen. We're not learning anything new here. On Wednesday, in our lecture, in class, we said that the degree of a term is the sum of the degrees of the variables in that term. Is there a variable there?
No.
No. So it's like this is x to the 0. And anything to the 0 is 1, and 1 times anything is the same. So that's 0. What is the degree of this term?
1. Oh, 2.
It's 2, because it's the sum of those, and there's 2 of them there. What's this one then? Everybody!
4.
4. And this one?
5.
5. What's the degree of the entire polynomial?
5.
The greatest degree of any one term. Good job, okay? Was that new or a review?
Review.
You already know all this stuff. Same crap, more variables. Look at, see, look at x, y, more variables.
So
Okay?
it's like the same crap, different smell.
Yeah, same crap, different stink. I like that. I can do that. Okay. All right. Part C. Part C. Combine like terms. And here we go again. So what I'm trying to share with you, just so you are understanding this completely, all right? This is straight from 4.3, but we're doing it in 4.7, okay? Again, this is straight from 4.3, but we're doing it in 4.7. It's combine LT. I want you guys to do me a favor right now, okay? Actually, you know what? I'll do this. Somebody though, read me. Number 26. Read 26 to me.
3.
You got it.
X squared, 3x squared, y, minus 2z squared y, plus 3x y squared, plus 5z squared y.
Okay. Every eye up here. We defined like terms a while back ago, just on Wednesday, and we said they have the same variable and degree combination. How many terms do I have?
4.
4. How many variables are there?
3.
There's 3. There's x's and y's and z's. X squared y. Is that an x squared y?
No.
No.
Is this?
No.
Is this?
No.
We're done with that, Fetcher. Cross them out, put them in the answer, right? Because we're combining like terms. Z squared y. Is that a z squared y?
No.
Is that?
Yes.
Yes.
Yeah. Negative 2, positive 5, what does that make?
Negative 10. Wait.
Plus 3
Oh,
z squared y. And those are gone, and so that one has nothing left to attach to, so it just comes into the answer. These are not like terms. Done. Hard or easy?
Easy.
But there's more variables, so you gotta be more organized, more thorough, right? Same crap you've been doing? More variables. Cool?
Cool.
Or not cool, but you're cool, because you know how to do it. Yeah? Okay, flip the page. D and E. Okay? Did you like this little quiz?
Yeah.
Te gusta? No gusta? Fecharusta?
I didn't forget about my negative exponent rule, so it was a good reminder.
Good review.
Yep.
Yeah, listen, guys. 8 problems to start the test. Right up here on the board. Look just like it. Yeah, you got to do this. Okay? Just finish erasing this.
He's gonna have you clean the boards again, Alex. You did too good of a job.
What's that?
I was just telling Alex that he did too good of a job. You're gonna have him clean the boards again. Yeah, they were really clean.
Did he polish them?
Not today.
In the video last.
Oh, in the video?
Yeah.
Oh, yeah, he did, man. Dude, he's the karate fetching kid. Wax on, wax off, ink on, ink off. You got it. It's cool, man. Remind me to teach you Crouching Tiger, Hidden Dragon, okay?
Okay.
Crouching Tiger, Hidden Dragon?
Yeah,
What is that from?
it's a movie.
Sounds like Big Trouble.
D and E. D and E. Okay, again, this is not from 4.3, but it is from 4.4, but we're reviewing it in 4.7, and it's the addition and subtraction of polys. And so I want you, this time, from numbers 29 to 39, pick a problem, any problem, I will do it. Pick one that's nasty, pick the nastiest one you can find, 29 through 39.
38.
Okay, read it.
Parentheses 3y to the 4 x squared plus 2y to the 3x minus 3y minus 7, close the bracket, minus, open bracket, 2y to the 4 x squared plus 2y to the 3x minus 4y minus 2x plus 5.
Yeah! You're a baller. That's a big one, man. Look up here, okay?
38.
All eyes up here. If that was a plus, it would be the addition of polys, right? Would I need any of the parentheses?
No.
No. Do I need the first parentheses?
No.
No, I don't. So the first thing I want you to do is I want you to erase this crap here. Okay? And then the next thing I want you to do is I want you to come in here, and I actually want you, right now, I want you to make that a minus, make that a minus, make that a plus, make that a plus, make that a minus, and now go ahead and get rid of this parentheses. You cool with that? Are you cool with that?
Yes.
I mean, you know how to do this stuff. Now, can I show you something else that's interesting here? Y to the 4th x squared. Do you have another y to the 4th x squared over there?
Yes.
Yes.
Okay, bring it over here, negative 2, y to the 4th x squared. Okay, you cool with that?
Yes.
Now watch what I'm doing here. I'm going to go, okay, and I'm going to go, okay. Now, do I have a y to the 3rd x?
Yes.
Yeah.
Okay, so I'm going to say minus 2y to the 3rd x. Those are going to cancel, that's lovely, but we can do that later. Okay, cross that out. And we're going to go, okay. Do I have another y term?
Yes.
Yeah, so we're going to put plus 4y here. Am I doing this a little different than I've ever done it before?
Yeah.
Yeah, I mean, usually I use the symbol method. This is just another way of being organized. And just another way that you could organize stuff. And it's just kind of organizing it vertically. It can be really effective when you have a lot of variables and a lot of terms. Okay, so we go ahead and okay. Do I have another numerical term?
Yes.
Yeah, negative 5. Okay, notice that I have that 2x term. It didn't come over. So I do have to put that in the answer. And so I'm going to go ahead and put it right here because it was in between the y and that term. Okay, now let's go ahead and let's combine these. 3 minus 2 makes what?
1.
And so we're just going to call that y to the 4th x squared because 1, we don't write the 1. Agreed?
Agreed.
Okay. And then these do what?
Cancel out.
Bye-bye. Okay? And negative 3 plus 4y makes what?
Y.
Plus y plus... All right. Got a little distance there. Plus 2x. And negative 7 and negative 5 make what? Negative 12. Okay, you guys cool?
Yeah.
All right. Hard or easy?
Easy.
Again, same crap you've been doing, more variables. We're spending way more time on this than you need to, just to make sure you're super uber goober duber comfortable. Okay? You good? You're good. Okay, I'm gonna pick one in F. Okay, we're gonna drop the F bomb on you. Because Austin loves the F-bomb. He uses it all the time.
Yeah.
Yeah.
Facts.
Facts. There you go. There's a good F word.
Yeah.
Okay. All right. Will somebody read problem number 60 to me? 60. Go ahead. I'm ready.
3a squared b minus b squared, all in parentheses, squared.
Let's look at this for a second, guys. Okay. So last night we were dealing with stuff like x plus 3 squared. How many variables in that expression?
2.
No, right here.
Variable 1.
1. How many in this one?
2.
2. Okay. And that's going to be so easy to do because we're going to take x plus 3, right? Because we cannot take a shortcut. And we're going to multiply all that out, blah, blah, blah. But this one here, same thing, same concept, 3a squared b minus b squared times, can't take a shortcut, 3a squared b minus b squared. But we've got to go through and do all the work. I'm going to do this with you really fast, and I'm going to teach you the last concept. Look up here. I like to say on my organization, and I put this in the video, I like to take 3a squared b and multiply it times the second parentheses, 3a squared b minus b squared. Then I like to drop down the negative b squared and multiply that times 3a squared b minus b squared. Understood what I did? I took this term right here times that parentheses right there. This term right here times that parentheses right there. Okay. Now I'm going to take, look up here, 3a squared b times 3a squared b, right? This times this, plus 3a squared b times negative b squared. This times this. Then I'm going to say plus negative b squared times 3a squared. This times this. And then plus negative b squared times negative b squared. Okay? This times this. I have 1, 2, 3, 4 mono times monos. Yes?
You missed a b in the second 3a squared.
Oh, I missed the a squared b right there. Correct?
Yes.
Thank you. Okay, be thorough, be organized. Thank you. Numbers with numbers. 3 times 3. A's with A's. A squared, B's with B's. B, B. I get what? Help me.
9 to the 4th b squared.
Very good. 9 to the 4th b squared. This one right here. Everything's in order except 3 and negative 1 make what?
Negative 3.
Negative 3. A squared. B times B squared makes B to the third. This one's going to be, look at this. I'm going to rearrange this. I'm going to have the 3 and the negative 1 because that's a negative 1 there. A squared and B squared and B. So I'm going to get what? Negative 3 A squared B to the
Third.
Oh, these two are the,
Same.
do they eliminate each other or will they combine?
Combined.
They will combine. Okay, and then this last one, negative b squared times negative b squared, what's that going to be? Plus b to the 4th, all right? And these combine to make negative 6a squared b to the thirds, the b to the 4th, and the 9a to the 4th b squared drop down. We're done with that, okay? Listen, guys, that is everything in section 4.7. You've really learned nothing new. You've just reviewed thoroughly what you can do. Now, did you read the announcements at the beginning of Canvas?
Yes.
Do you understand what EOO means?
Yes.
No.
Okay.
I did not know what it meant.
Well, do you understand now?
Yes.
Good.
Now I do.
What?
Now I do.
Good. Okay.
Did you get the email over the weekend?
I just sent that email today about EOO.
No.
Well, someone sent an email out.
Like last
I
week.
can't remember.
TAs did.
Can't remember.
Oh,
who
it's
it
Cal, I think.
About-
Okay. Listen up, guys. If we do 1 through 81 odd, we cut that assignment in half. Instead of 81 problems, we now have 41 problems. If we do every other odd, we cut it in half again. Instead of 41 problems, we have 21 problems, okay? So EOO is super helpful. But if you were doing even odd, or, every other whatever, I don't know. So listen, if you did it, it's fine. We give a point a problem. You probably got extra credit, okay? You probably did more problems than you had to, but do every other odd, okay? Because there's going to be a lot going on in this last few weeks of school. We don't want to overwhelm you with lots of busy work, okay? You guys cool? But in this assignment tonight, it tells you to do every other odd, but it does tell you to do both number 17 and 19. Just look at the directions. It tells you exactly what to do, okay? All right, take a picture of this. I got to teach you one more concept. One more. It's not time to go. Almost, though. Okay, if you want to take pictures of what's on the board, go for it. I am going to erase the middle board. And I need you to keep your book open for just a second, but I want you to go to section 4.8. Okay? Am I in your way? I don't want to be in your way. Go ahead and somebody's way. Can I erase this? Yes or no?
Yes.
Yes.
Oh. Okay. I didn't do number 62. And the good news is 62 actually was not an assigned problem. And we are going to talk more next time about a review of multiplication of polys even more. But you guys probably got a pretty good review just there. Put us in section 4.8. It is division. I need somebody to read problem number 24 to me. Number 24. Go ahead, I'm ready.
4x to the 4th y minus 8x to the 6th y squared plus 12x to the 8th y to the 6th over 4x to the 4th y.
Okay. Do you all understand that problem right there and this problem right here that I am writing, whoops, that's a y, 6 in parentheses divided by, are the same? Do you see that?
Yes.
This divided by this equals this divided by that. Yes or no?
Yes.
Okay, so the first thing I want you to understand is in your homework, they could be written either way. In the test, it could be written either way. You good?
Good.
Okay. Division of polys. You know how in multiplication of polys, we had, mono times a mono, mono times any poly, right? Well, in division, we also have something similar where we have like any, poly divided by a mono, any poly divided by a bi, any poly divided by et cetera, et cetera. Well, in beginning algebra, we only cover this. So please listen, there are over 40 problems in section 4.8. We only do 1 through 23 odd, which is 12 problems. We're going to do the hardest problem right now. That's the hardest problem in the homework right there. Watch this. Step number 1, place the mono under each term in the poly. So we're going to take 4x to the 4th y and put it over 4x to the 4th y minus 8x to the 6th y squared over 4x to the 4th y plus 12x to the 8th y to the 6th over 4x to the 4th y. Understood? And do you understand? Look up here, please. Do you understand that this and this are the same? We've talked about this principle before. An entire numerator over a single denominator, you can take each term and place it over that denominator. Yes?
Yes.
That's step number 1. Step number 2, and it's the last step, you're going to be done here in a minute, simplify. And how do we simplify? The same way that we multiply polynomials. Numbers go with, numbers. X's go with X's. Y's go with Y's, etc., etc., etc. Okay? Everybody help me. Please help me. Okay? We're gonna literally go and. Okay? 4 divided by 4 is what? 1. X to the 4th over X to the 4th is what? 1. Y over Y is what?
1.
So what am I left with right here?
1.
Oh, I love you. Now and then I get students say, nothing. First of all, there's no such thing as nothing in math. Nothing doesn't exist in math. 0 does. So then they revert to 0. I'm like, that ain't freaking 0. Anything divided by itself is 1. Good job. All right, watch this. Numbers with numbers, so I'm just making a little divider there. 8 divided by 4 is what? 2. X to the 6th over X to the 4th, well, the quotient rule. Same base. X to the 6th over X to the 4th is X to the second. Fetch me. Y to the 2nd over Y is what?
Y.
Just Y. Okay? All right, what are we going to do here, you guys? We're going to cut this. We're going to cut this. So what's 12 divided by 4?
3.
Y, X to the 8th over X to the 4th?
X
Fourth.
to the 4th.
And Y to the 6th over Y?
Y to the 5th.
Y to the 5th. And you're done. Hard or easy?
Easy.
And that's the hardest problem in 1 through 23 odd. And that's an extra credit one. It's 24. And that's everything you need to know. Now let me share something with you as you wrap up. Everything in chapter 4 is now published. Your last tutor challenge, division of polynomials, published. Okay? Your test is published, but it's not available until midnight on Wednesday. Okay? Well, really, 12:01 or 12 a.m. on Wednesday. Okay? Next thing, all your assignments, you listen to this, 4, 7, 4, 8, but also the visual chart and the review in blue are all published. Wednesday, we will complete the review. We've done 10 of the problems on the test. We will review the other 15. If you choose To take the test, you must first complete the visual chart and the review in blue, which aren't due until Friday. 4.7 and 4.8 are due Wednesday, but the review in blue and the visual chart aren't due till Friday. But if you want to take the test, you got to get it all done. But if you take the test and you get an A, which in this class, 93 is an A, but on a test, you have to get, there's only, with 25 problems, you either get a 100, a 96, or a 92. If you get any of those three scores, you don't have to come to class on Wednesday. But you have to email me and say, Brother Rich, you're so handsome, and I just love the way you teach. I'm bringing you a bag of Jolly Ranchers. I don't know, whatever you want to say, but you got to tell me you got an A on the test. Now, if you lie, I'm going to be looking it up because I got to record it, and then I'm going to be like, you punk A kid, and A doesn't stand for apple, okay? So listen, you send me an email, you tell me you got an A, and you don't have to come to class, and you get credit for the attendance or quiz on that day, even if you don't come. If you get an 88, please don't email me saying, I got an 88, can I please not come? No, you got to come. What's up?
Do you want us to CC Alex?
You can CC Alex, but it'll only fill his inbox. I'm the only one who really cares.
Is this next week or
Okay.
this week?
This is like literally in the next 48 hours. Okay, you guys cool?
Yes.
Cool.
Okay. Have a good one.